silver wires and gold wires, which are much more rare, even though that they've been known for hundreds of years, we know very little about them. We've been studying wire silvers, how they grow. We have some hypotheses that we've developed based on our characterization of the texture and the crystallinity. We have no idea in the context of gold. So the first thing we have to do is look to see, are these the same thing as silver wires in terms of their internal structure and their texture?
It was one of the first gold rush specimens, gold specimen. It was described on a newspaper in 1893. And there is a drawing of the wire. Back then someone bought it for $160. So already in the 1893 it was considered a unique specimen in many aspects.
The specimen that we're looking at from Harvard University is hands down the very finest example of that ever discovered.
Here at the Los Alamos Neutron Science Center, we use neutrons to characterize materials. Here at LANSCE, we have our half-mile long accelerator that provides us with a very intense source of pulsed neutrons. We then use those neutrons to characterize materials. One parameter that we measure is the orientation of the little crystals or grains that make up a large chunk of material. We normally use this method to materials that are relevant to the Los Alamos mission, such as uranium alloys or nuclear fuels. But we sometimes get to apply it to, for instance, geological samples, like this very famous gold sample.
That's why we are here in LANSCE. Thanks to the facilities and the instruments, we can really look through and see what it's made of, how it crystallizes, the texture. There are many different types of studies that we can do.
The gold sample that we characterize looks like a bundle of wires, and while that is very typical for silver, it is very, very rare for gold. We characterized a few silver samples also to have a comparison, and what we found in the silver sample is that the silver is made up of many, many small grains, and their little crystals all share one special crystal direction with the axis of those little wires. Because a big gold sample looks very similar to these silver samples, we expected something similar for that gold sample. And we were very surprised when we analyzed our data and we saw that in the gold it looks much more like there are just a few very large crystals and not these many, many small grains that we found in the silver.
This is actually a wire silver. We find them in nature. We can grow them in the laboratory. There are aspects of the growth mechanism that we think have technological applications or potential applications.
They push the envelope for us, these academic collaborations. And of course, it's a lot of fun too to apply these methods and help the universities to gain insight that otherwise they would have no chance to gain. So it's a win-win situation for Los Alamos and the universities.